Hello there, let's take some time to practice the humble division sum. Now you'd be surprised how many people, when faced with a question like this, 1275 divided by 3, forget that the sum can be set up like this, and we'll go straight into doing a chimney sum or trying to work it out mentally. But today we're going to be looking at these sums here, where you've got your dividend on the inside, your divisor, the number that you're dividing by, on the outside, and you've got this kind of bus stop or toaster or whatever you want to call it, and your answer, your quotient, will pop out the top. We're going to look at a few different types, first of all being whole number divided by a single digit to get a whole number answer. Then we'll have a look with some decimals, because we're going to have no digits left behind here today, as in we're not dealing with remainders. And then at the end, I might show you some long division. So first of all, we're looking at our sum here, and we need to think to ourselves, how many 3's will go into 1? The answer is none. You cannot fit a 3 into a 1. So that 1 carries on, and we now look at 12. How many 3's could I fit into 12? That's going to be 4. No remainders here. Next one, how many 3's could I fit into 7? If I have 7 of something, I can make a group of 3 here, a group of 3 here, and I will have 1 left over. So I can get 2 3's and 1 left over, and that 1 will carry over onto that 5 to make it a 15. Now, how many 3's in 15? 5, and that's us done. Next one, 741 divided by 4. Now we can tell that there's going to be a remainder here, because it doesn't matter how long the number is, if the last 2 digits are divisible by 4, the whole number is divisible by 4. 41, not so much divisible by 4, so 741, not divisible by 4 in a whole number. Set up your division sum, and then we'll just follow the same method here. How many 4's can I fit into 7? Well, I can go up my 4 times table. 4, 8, bust, too much. So only really 1 4 and 3 left over. Okay, how many 4's into 34? Well, 4 times 8 would be 32, so I can definitely fit 8 of them in. And from 32 up to 34, I will have 2 left over. And now, how many 4's in 21? Oh no, I can fit 5. 4 times 5 would give me 20. And then I've got this 1 left over, but what am I going to do? Okay, previously you might have put remainder 1, but now what we can do is look at 741 and say, hey, 741, well, that's the same as 741.0, and I can go ahead and put my remainder on that. And now, how many 4's are going to go into 10? Decimal point, 2 up here, another 2 left over. Okay, it's fine. There's as many zeros as I want or need. I can keep making this 741 point infinite zeros if I wanted. Not the best use of your time, but still. How many 4's fit into 20? That's a 5. And there we go. 741 divided by 4 is 185.25. Up next, what happens if we already start with a decimal? Literally nothing. You set up your division sum the exact same way. Cool thing about division sums is if the decimal point is here in the question, you can just put the decimal point ready and waiting there for the answer. How many 5's go into 0? None. How many 5's go into 1? Also none, but with a remainder of 1. How many 5's in 12? Well, 2 5's would be 10, and I've got a remainder 2. And how many 5's in 25? That's 5. 0.025. And finally, let's have a look at this one here. 1.5 divided by 8. Set up my division sum, ready to go with the decimal waiting for the answer, lined up. How many 8's go into 1? None. Remainder 1. How many 8's go into 15? So close to being 2, but it's not. It's just 1, and there's a remainder 7. But where am I going to put that remainder? Well, I could put a 0 on here. Got as many of those as I want after the decimal point. How many 8's go into 70? 8 8's is 64, and so then I'm going to have a remainder of 6. Put that on another 0. How many 8s go into 60? 7 8s is 56. Oh no, still more remainder. Okay, so that would leave me with 4 left over. Another 0. Put a 4 on here. How many 8s go into 40? 5 exactly. There we go, 0.1875. Now, there is absolutely no requirement in secondary school to learn long division anymore. This is beyond level 4 at the BGE, but it's a thing that exists in the world and it's actually quite cool to know and might help you a little bit with algebraic division in the future. So, it works similarly to regular division, except your sum is going to go down the way, so you need quite a lot of space here, quite a few rows of working to do a long division sum. So we set it up the same as before, 768 divided by 12, but now you need a big long line going down the way to try and find your answer. And what we're going to do is we're basically going to try and build 768 out of blocks of 12 that we know. So 10s, 20s, multiples of 10 are really good for this, or hundreds if you can fit them in. So when I look at 12, I think, well, 10 12s would be 120, 20 12s would be 240, and I can definitely fit one of those into 768. So I go 240, that would be 20 lots of 12. And then I'm going to take them away and see what I'm left with. So 768, take away the 240, gets me 528. Could I get another 20 out of that? Yeah. Could I maybe even get a 30 out of that? You want to try and get the biggest one that you can think of, although it doesn't matter if you don't think of them first time. I reckon we could get a 30 out of that because that would be a 360. Subtract again. 12 take away 6 gives me 6. Okay, 168. We're homing in, we're getting closer. I can definitely get 10 out of that because I can fit 120 in there. What would I be left with? 48. And that works out perfectly because 4 times 12 is 48. So I have now essentially built 768 out of all of these different blocks of 12. I used 20 lots of 12, 30 lots of 12, 10 lots of 12, and 4 lots of 12 altogether. So that gives me 64 lots of 12. So 768 divided by 12, 64. Okay, what about this one over here? It's not going to work out so nicely. So set up my sum. Nice big long line here. Okay, I reckon, so I'm using groups of 15, I could fit 1,500 in here, which would be 100 lots of 15. So, little note to myself, that was 100 lots of 15. Let's take that away. I mean, you can probably do that in your head. We've got 500 left. Okay, now I'm thinking about blocks of 150, because that would be 10 15s. How many 150s could I get into 500? Well, 150, 300, 450. So I can make 450 using 30 blocks of 15. Let's take that away. I've got 50 left. Okay, so if I used 3 15s, that would get me to 45. And then I've got this 5 left over, but I'm never going to be able to make 5 out of blocks of 15. So that becomes a remainder, which we are going to write as a fraction. So my final answer here is 133 and 5 over 15. Always simplify your fractions, so 133 and a third. And that, just for the sake of fun, is how you do long division.